All right, we're going to practice solving some polynomial and rational inequalities. So we're going to write the solution set using the intervals that satisfy the given inequality. We'll use interval notation. If we're solving a rational inequality, be certain to include the numerator boundary points only, not denominator, if the inequality contains the or equal to. All right, so we've got 3 polynomial inequalities and 3 rational inequalities down here. So polynomial inequalities. Step 1, set one side of the inequality to 0. So in example 1, 2, and 3, that's already done for us. So, and then we take the polynomial f of x and we set it equal to 0 to find the boundary points. Nice thing done here for us already is the factoring. So either x equals 7 or x equals -9. Those are our boundary points. So I'm going to go ahead and get a number line going here. So I have -9, I have 7. These are my zeros, so I put zeros above these points, these boundary points. Let's start doing some test values. So we're going to test x equals -10 first. That'll put us in this interval. So f of -10. So -10 minus 7 and -10 plus 9. And again, we don't really care what the answer is. We care if it's positive or negative. So this is going to be a -17 or just negative number. This is going to be a -1. So a negative times a negative is a positive. So we're going to record pluses up here in this interval. Let's test x equals 0 because that'll fall between these two numbers. So f of 0. So back up here, we're going to have 0 minus 7 and 0 plus 9. So we know this is negative, this is positive, we're multiplying, so we're going to get a negative solution. So we're going to record negatives here. And then we'll test x equals 8. So 8 minus 7 and 8 plus 9. This will be +1, +17. A positive times a positive is a positive. All right, what solutions do we want? Do we want to circle the positives or the negatives because it's one or the other? Well, we need to look back at the original problem. We want the greater than or the positive solutions. And then we want to do the graph. Okay, example 2. All right, the polynomial inequality is already set to 0. So let's set the polynomial equal to 0. I want to factor. Notice there's no constant, so I don't need to do a factor sum chart. Let's just pull out the x. Set each factor equal to 0. So one of the boundary points is 0. And then from this factor, the other boundary point is 4. I think I'll go ahead and get ready here. And I'll put 0 and 4. And it's kind of crowded. So this is a 0 above here and a 0 above here. Let's get to our test values. I'll test -1. You could test -1 back into the factored version, or you can test it back into the original. It might be just as easy to test it in the factored version, since all we care about is not just the specific answer, but whether that answer is positive or negative. So I'm going to put a -1 in here, and then I'll put a -1 in for this x minus 4. So this is negative, and this result would be a negative. So a negative times a negative is positive. So I got a bunch of pluses up here. Let's test x equals 1. So I'm going back to the factored version. So this is 1 times 1 minus 4. And I know 1 is positive, and this will be a negative number. So positive times negative is negative. And then we'll test 5. So it's 5 times 5 minus 4. And we've got positive times positive, so that's going to give us a positive solution. All right, so we want the solution and the graph. All right, what are we choosing, positives or negatives? Well, I'm looking back at the inequality. I want the positive solutions and also the or equals 0 solutions. So I want the positive one, so that's going to be this part of the number line and this part. So my solution is negative infinity to 0 with a bracket and union 4 to infinity. And we'll do a bracket and darken in these solutions. All right, let's solve this polynomial inequality. It's set to 0. Okay, and so we're going to actually set the polynomial equal to 0. Okay, this is quadratic. You can go to the quadratic formula. You can do a factor sum chart. So to remind ourselves, factors of a times c are 63 that sum to negative 16. 7 and 9, I think. So the factors are 1 and 63, 3 and 21, and I believe 7 and 9. Let's make both 7 and 9 negative, so that does give us negative 16. So the factorization is x minus 7 and x minus 9. So from here, our two boundary points would be x equals 7 and x equals 9. So let's organize our work. 7, 9. These are our zeros. Let's test an x value less than 7. So let's make a good choice and test x equals 0. You can plug 0 back into the original problem, which that would probably be the smarter choice, because if x is 0, this term goes to 0, this term goes to 0, and we're left with 63, which is positive. So we've got some pluses here. Let's test x equals 8. For me, instead of plugging 8 back in here, I'd probably plug 8 here and 8 here in the factored version. So 8 minus 7 and 8 minus 9. So 8 minus 7 is positive, but 8 minus 9 is negative, and I have to multiply, so I get a negative answer. And I'll test 10. I can plug 10 back here and here, but I might as well plug in 10 here and 10 here. So 10 minus 7 and 10 minus 9. So positive multiplied, give me a positive solution. Do we want positives or negatives? It's only one. We want actually the negative solutions and the 0 solutions. So that would be right here. All right, so our solutions would be 7 to 9. Brackets because of the or equal. Brackets will face inward, so I can bold this part of the solution number line. Okay, let's do 3 rational inequality examples. All right, make sure that in all problems we have a 0 on one side of the inequality. We do. The first step was to set both the numerator and denominator equal to 0. I might actually do that over here to give myself some more room. So x plus 3 is 0, so x equals negative 3, and x plus 2 is 0, so x is negative 2. These are our boundary points. negative 3 will come first and negative 2. All right, these are our boundary points. X equals negative 3 came from the numerator, so I'll put a 0 here. X equals negative 2 came from the denominator. We don't want to divide by 0, so we put undefined. And then we're just going to do test values. So negative 4 minus 3 and negative 4 plus 2. So our numerator will be negative and our denominator will be negative, divide, and we get a positive result. Let's test x equals negative 2.5. So negative 2.5 minus 3 and negative 2.5 plus 2. So the numerator is negative and the denominator is also negative. So, why is that? Negative 4 minus 3, negative 4 plus 2. Oh my goodness. I set this equal to, I am so sorry. Oh my goodness, that's going to mess everything up, isn't it? This numerator, you probably noticed, was x minus 3. I don't know why I made it x plus 3. Let me see if I can fix that without having to like erase everything. Oh my goodness. X minus 3 is 0, so that is going to mess everything up. Oh goodness. Okay, so that's going to be x equals positive 3, but this is negative 2, so that's going to mess these up right here. Let me see if I can fix this. Holy cow, it's going too fast. I think I will try and fix this. You probably saw that earlier, and I'm just now catching myself. Okay, but I knew my math wasn't making sense because I should have a sign change. Oh, goodness. Let me see. I'm going to put negative 2 over here and 3 here. Negative 2 is still undefined, and 3 is the 0. Okay, well, my test value of x equals negative 4 is okay. So I'm going to leave negative 4 in here, and it's minus 3, so this is a positive. Let me now switch out with this test value, and instead of using negative 2.5, which would put me still over here with a positive, let me now use 0. Oh, goodness, so sorry. Test x equals 0. Let's fix that, and let's fix this. So this is going to be 0. Okay, so now I've got 0 minus 3 and 0 plus 2. There we go. So I'll have a negative numerator, positive denominator, divide, and I get a negative. Yeah. They don't always have to change signs, but I knew that this one was going to, so I knew that when I got the same sign, I must have made a mistake. All right, and then let's test x equals 4. Thanks for your patience on that. I was too far into the video to have to like change it and redo it. All right, test x equals 4. So 4 minus 3 and 4 plus 2. So positive top, positive bottom, divide, and we get positive. There we go. All right, so what do we want? Positives or negative? I look back at the original problem. I want the positive solutions, but not the zeros. So the solutions would be negative infinity up to negative 2, and then 3 to infinity. All right, we'll look at 5. All right, one side of the inequality is 0. You can factor the numerator and denominator if you want to, but for what we're doing, you might as well just go ahead and set the numerator equal to 0, find the boundary point, and same thing with the denominator. So negative 2x equals negative 6. So x equals 3. I could have done the work up there. Maybe I'll do the work up here for the denominator. X plus 1 is 0. So x equals negative 1 is another boundary point. So we've got -1 and 3. X equals -1 comes from the denominator, so that's your undefined. And x equals 3 comes from the numerator, so that's a 0, and that's okay. We can include numerator boundary points, but not denominator. And then we'll do test values. So let's test x equals -2. So -2 times -2 plus 6, and -2 plus 1. So that's positive plus 6. This is a positive numerator, negative denominator. So we're going to have negatives over here. Let's test x equals 0. So -2 times 0 plus 6, and 0 plus 1. That goes to 0. So we have positive top and positive denominator. Divide, that's positives here. And then we'll test 4. Test x equals 4. So -2 times 4 plus 6, and 4 plus 1. So we have -8 plus 6, which is -2, and then this is positive, divide, and we get negatives. All right, so our solution is kind of crowded. What do we want? We want greater than, so we want the positive solutions. So that would be don't include -1, and it's not equal to 0, so we put a parenthesis at the other end. And then we've got a graph. So -1 and 3. 2 parentheses and bold. Okay. Right, and I think I'm going to leave 6 for you. The worked out solution will be on my key, so you might want to kind of self-assess, see where you're at with that rational inequality. Hope this helped.